Welcome to Strides to Solutions. I'm Esther Adams, and today we're diving deep into one of the most complex and misunderstood neurological conditions of our time: attention deficit hyperactivity disorder, or ADHD. What we're going to explore together isn't just another surface level discussion about symptoms and medication. Instead, we're going to journey into the intricate biological mechanisms that shape how the ADHD brain develops, functions, and experiences the world. The research I'm sharing with you today comes from cutting edge neuroscience that's revolutionizing our understanding of ADHD. This isn't about quick fixes or simple explanations. It's about honoring the complexity of the human brain and recognizing that ADHD represents a fundamentally different way of neural development and function. Let's start at the most fundamental level: the cellular powerhouses that fuel our brains. Recent research has uncovered something quite remarkable. People with ADHD show consistent patterns of mitochondrial dysfunction. Now, you might wonder why we're talking about cellular energy when discussing attention and hyperactivity. The connection runs deeper than you might expect. Mitochondria are often called the powerhouses of our cells, and in the brain, they're absolutely critical. Every thought, every moment of sustained attention, every act of impulse control requires enormous amounts of cellular energy. When these microscopic energy factories aren't functioning optimally, the ripple effects reach into every aspect of cognitive function. The research shows us that individuals with ADHD have reduced mitochondrial respiration, impaired ATP production, and altered mitochondrial DNA copy numbers. What this means in practical terms is that the brain cells themselves are working harder to generate the energy needed for complex cognitive tasks. Imagine trying to run a high performance computer on a battery that's not holding its full charge. Everything still works, but it requires more effort and may not perform at peak capacity. This cellular energy deficit helps explain why people with ADHD often experience mental fatigue more intensely, why sustained attention feels so effortful, and why their brains might seek out stimulation to maintain optimal functioning. It's not a character flaw or a lack of willpower. It's a fundamental difference in how their brain cells generate and utilize energy. What's particularly fascinating is that this mitochondrial dysfunction appears to be linked to genetic variations. Certain mitochondrial gene variants are more common in people with ADHD, suggesting that this energy regulation difference has deep biological roots. This isn't something that develops from poor habits or environmental factors alone, though the environment certainly influences how these genetic predispositions express themselves. One of the most profound discoveries in ADHD research concerns the timing of brain development. Longitudinal neuroimaging studies have revealed that children with ADHD experience a significant delay in cortical maturation, particularly in the prefrontal cortex, the brain region responsible for executive functions like planning, impulse control, and sustained attention. This delay isn't subtle. Children with ADHD reach peak cortical thickness in their prefrontal regions about 3 years later than their typically developing peers. Think about what this means. A 10-year-old with ADHD might have a prefrontal cortex that's functioning more like that of a 7-year-old in terms of its developmental maturity. This delayed maturation pattern helps us understand why traditional behavioral expectations often feel impossible for children with ADHD. We're essentially asking them to perform cognitive tasks with brain circuitry that hasn't fully developed yet. It's like expecting a child to reach something on a high shelf before they've grown tall enough. The physical capability simply isn't there yet. But here's what's crucial to understand: this isn't a deficit in the traditional sense. The brain does continue to develop, and many of these circuits eventually mature. However, the timing difference means that individuals with ADHD often face years of feeling inadequate or defective when they're actually dealing with a neurodevelopmental timeline that's perfectly valid for their brain, just different from the typical pattern. The prefrontal cortex is particularly important because it acts as the brain's CEO, coordinating and controlling other brain regions. When its development is delayed, we see the characteristic ADHD symptoms: difficulty with working memory, problems inhibiting impulses, challenges with cognitive flexibility, and struggles with planning and organization. What's even more interesting is that this delayed development isn't uniform across all brain regions. Some areas develop typically, while others lag behind, creating an uneven developmental landscape that can be both challenging and, in some ways, advantageous. This unevenness might contribute to the often remarkable creativity and out of the box thinking that many individuals with ADHD demonstrate. The neurotransmitter systems in ADHD brains function differently, and understanding these differences is crucial for developing compassion and effective interventions. The research shows that dopamine and norepinephrine dysregulation patterns actually differ across ADHD subtypes. In the predominantly inattentive subtype, we see more pronounced deficits in prefrontal dopamine and norepinephrine function. This manifests as difficulties with sustained attention, working memory problems, and what might appear as daydreaming or mental fog. The brain is essentially under-aroused, struggling to maintain the chemical conditions necessary for focused attention. The predominantly hyperactive impulsive subtype shows different patterns, with more disruption in striatal and subcortical dopamine pathways. This leads to the restlessness, impulsivity, and difficulty with behavioral regulation that we often associate with ADHD. The combined subtype, as you might expect, shows elements of both patterns, creating a more complex neurochemical landscape that requires nuanced understanding and intervention approaches. What's particularly important to understand is that these neurotransmitter differences aren't just about attention and hyperactivity. Dopamine and norepinephrine are involved in motivation, reward processing, emotional regulation, and even physical coordination. When these systems are dysregulated, it affects the entire experience of being human. This helps explain why ADHD is rarely just about attention problems. It's a condition that touches every aspect of functioning because these neurotransmitter systems are so fundamental to brain operation. The person with ADHD isn't choosing to be disorganized or struggling with motivation. Their brain's chemical messaging system is operating with different parameters. One of the most enlightening discoveries in ADHD research involves the default mode network, a system of brain regions that's active when we're not focused on specific tasks. In typically developing brains, this network quiets down when we need to focus on something external. But in ADHD brains, this system doesn't deactivate properly. This leads to what researchers call excessive spontaneous mind wandering. The internal world remains active and intrusive even when external focus is needed. It's not that people with ADHD choose to let their minds wander. Their brains have difficulty suppressing the internal dialogue and imagery that normally gets pushed to the background during focused tasks. Imagine trying to have a conversation in a busy restaurant where you can't tune out the surrounding noise. That's similar to what happens in the ADHD brain during tasks requiring sustained attention. The background mental activity doesn't fade into the background. It competes for cognitive resources with whatever task is at hand. This default mode network dysfunction also helps explain why people with ADHD often struggle with boring or repetitive tasks, but can hyper-focus on activities that are intrinsically interesting or stimulating. When something captures their interest, it can override the competing internal activity. But when tasks are understimulating, the internal world becomes more compelling than the external demands. Understanding this helps us reframe ADHD behaviors. The child who's staring out the window during a math lesson isn't being defiant. Their brain's attention system is genuinely struggling with the competing demands of internal mental activity and external focus requirements. The relationship between ADHD and circadian rhythms reveals another layer of biological complexity. People with ADHD consistently show disruptions in their internal biological clocks, including delayed sleep phases, altered melatonin production, and even changes in core clock gene expression. These circadian disruptions aren't just about sleep problems, though sleep issues are certainly part of the picture. Our circadian rhythms regulate hormone production, neurotransmitter synthesis, cognitive performance, and even cellular repair processes. When these rhythms are disrupted, it affects every aspect of functioning. The research shows that circadian misalignment in ADHD contributes to increased inattention, emotional dysregulation, and cognitive difficulties. It's like living in a state of perpetual jet lag, where your internal clock is out of sync with the external world's demands. This circadian dysfunction often manifests as evening chronotype, being naturally more alert and focused later in the day. This creates a fundamental mismatch with traditional school and work schedules that expect peak performance in the morning. The teenager with ADHD who can't focus during first period but becomes incredibly productive at 10 p.m. isn't being difficult. They're working with a circadian system that's naturally shifted. What's particularly challenging is that this circadian disruption can worsen other ADHD symptoms, creating a cascade of difficulties. Poor sleep quality affects emotional regulation, which impacts interpersonal relationships, which increases stress, which further disrupts sleep patterns. Understanding this cycle is crucial for developing effective intervention strategies. While ADHD has strong genetic components, environmental factors during critical developmental periods can significantly influence how these genetic predispositions express themselves. The research on prenatal toxin exposure reveals concerning patterns that help us understand ADHD risk factors. Lead exposure, even at levels previously considered safe, shows clear dose response relationships with ADHD symptoms. Prenatal exposure to pesticides, air pollution, and other environmental toxins can disrupt neurodevelopment in ways that increase ADHD risk. These environmental factors work through multiple mechanisms. They can increase oxidative stress, disrupt neurotransmitter development, alter gene expression, and even change brain structure. The developing brain is particularly vulnerable because it's growing so rapidly and lacks many of the protective mechanisms that mature brains possess. This environmental component is important because it highlights that ADHD isn't purely genetic destiny. While some individuals may have genetic vulnerabilities, environmental factors can influence whether and how severely these vulnerabilities manifest. This gives us hope for prevention and early intervention strategies. It also helps explain why ADHD rates vary across different populations and geographical areas. Communities with higher environmental toxin exposure often show higher ADHD rates, suggesting that these external factors play a meaningful role in the condition's development. Recent research has uncovered fascinating connections between gut microbiome composition and ADHD symptom severity. This might seem surprising, but the gut brain axis is increasingly recognized as a crucial pathway for mental health and cognitive function. People with ADHD show distinct gut microbiome profiles compared to typically developing individuals. Lower levels of beneficial bacteria like Fiacalobacterium are associated with greater symptom severity, while higher levels of certain other bacterial strains correlate with increased hyperactivity and impulsivity. The mechanisms here involve neurotransmitter production, immune system modulation, and the production of short chain fatty acids that can influence brain function. Some gut bacteria actually produce dopamine and other neurotransmitters that can affect mood and attention. When the microbiome is imbalanced, it can contribute to the neurochemical dysregulation we see in ADHD. This gut brain connection also helps explain why dietary interventions sometimes help with ADHD symptoms. It's not just about avoiding certain foods, it's about maintaining a microbiome environment that supports optimal brain function. The inflammatory component is particularly important. Gut microbiome imbalances can trigger systemic inflammation, which affects brain function and can worsen ADHD symptoms. This creates another cascade effect where digestive health impacts cognitive performance. ADHD manifests differently in males and females, and the research reveals that these differences have deep neurobiological roots. It's not just that boys are more likely to be diagnosed. The underlying brain differences between males and females with ADHD are substantial. Genetic factors show sex specific patterns, with certain risk variants affecting males and females differently. Hormonal influences, particularly estrogen and testosterone, modulate neurodevelopmental pathways in ways that shape symptom expression. Males with ADHD tend to show more pronounced structural brain differences, particularly in gray matter volumes. Females often show different patterns of white matter changes, especially in regions connecting the brain's hemispheres. These structural differences correlate with the tendency for males to display more external, hyperactive symptoms, while females often show more internal, inattentive presentations. The neurochemical differences are equally important. Males and females with ADHD show distinct patterns in dopamine metabolism and transporter function. These differences help explain why medications might work differently across sexes and why symptom profiles vary. Understanding these sex differences is crucial for accurate diagnosis and treatment. The traditional understanding of ADHD was largely based on studies of hyperactive boys, which led to systematic underidentification of girls whose symptoms might be less disruptive but equally impairing. These biological sex differences also interact with social and cultural factors in complex ways. Girls with ADHD often develop different coping strategies and face different social expectations, which can mask their symptoms while increasing their internal distress. The relationship between ADHD and autism spectrum conditions reveals important insights about neurodevelopmental patterns. These conditions show significant overlap in affected neural circuits, particularly those involved in executive function, attention, and social behavior. Both conditions frequently involve mitochondrial dysfunction, suggesting shared biological pathways. The frontostriatal and frontoparietal circuits that are disrupted in ADHD also show abnormalities in autism, though the specific patterns of disruption may differ. This overlap helps explain why many individuals receive diagnoses of both conditions and why some people seem to fall in between traditional diagnostic categories. The brain doesn't develop according to diagnostic manual categories. It follows biological patterns that may cross traditional boundaries. The mitochondrial connection is particularly intriguing because it suggests that energy regulation problems might be a common pathway for several neurodevelopmental conditions. When brain cells can't generate sufficient energy, different regions and circuits may be affected in different ways, leading to varied symptom presentations. Understanding these overlaps also highlights the importance of looking at each individual's unique pattern of strengths and challenges, rather than trying to fit them into rigid diagnostic boxes. The goal should be understanding how their brain works and what supports they need, regardless of which diagnostic categories they might meet. Beyond the biological mechanisms, we need to understand the psychological experience of living with ADHD. The constant awareness that your brain works differently from others can profoundly impact self-concept and emotional well-being. Many individuals with ADHD develop what researchers call masking behaviors, attempts to hide or compensate for their symptoms to appear more neurotypical. This masking requires enormous cognitive and emotional energy, often leading to exhaustion and burnout. The experience of chronic struggle with tasks that seem effortless for others can lead to learned helplessness and negative self-beliefs. When a child repeatedly hears that they need to try harder or pay attention, they may internalize the message that they're lazy or defective, rather than understanding that they're working with different neurological equipment. Executive function challenges affect not just academic or work performance, but emotional regulation as well. The same prefrontal cortex that struggles with planning and organization also helps regulate emotional responses. This means that individuals with ADHD often experience emotions more intensely and have difficulty modulating their emotional reactions. The social implications are equally important. ADHD symptoms can affect interpersonal relationships in complex ways. Impulsivity might lead to saying things without considering their impact. Inattention might make it difficult to follow conversations or remember important social information. Hyperactivity might make social situations feel overwhelming or cause others to perceive the person as intrusive. One of the most painful aspects of ADHD that often goes unrecognized is rejection sensitive dysphoria, an extreme emotional reaction to perceived rejection or criticism. This isn't about being overly sensitive in a character sense. It's a neurobiological phenomenon related to how the ADHD brain processes social and emotional information. The same attention regulation difficulties that affect focus also affect emotional processing. When someone with ADHD perceives rejection or criticism, their brain may not be able to regulate the emotional response effectively. What might feel like mild disappointment to a neurotypical person can feel like devastating emotional pain to someone with ADHD. This rejection sensitivity can become a major life organizing principle, leading people to avoid situations where rejection might occur or to interpret neutral interactions as negative. It can affect relationships, career choices, and overall life satisfaction in profound ways. Understanding rejection sensitivity as a neurobiological phenomenon rather than a character flaw is crucial for developing self compassion and effective coping strategies. It's not about being weak or overly dramatic. It's about having a nervous system that processes emotional information differently. While much of ADHD research focuses on deficits and difficulties, it's important to understand that the same neurobiological differences that create challenges can also generate strengths. The distractibility that makes it hard to focus on boring tasks can also lead to noticing details and connections that others miss. The hyperactivity that feels disruptive in traditional settings can translate into high energy and enthusiasm when channeled appropriately. The impulsivity that creates social and academic difficulties can also manifest as spontaneity, creativity, and the ability to take action when others hesitate. The hyperfocus ability that many people with ADHD experience represents the flip side of attention regulation difficulties. When something captures their interest, they can sustain attention for hours, often producing work of exceptional quality or depth. These strengths aren't consolation prizes or attempts to put a positive spin on a difficult condition. They're genuine neurological capacities that emerge from the same differences that create challenges. The key is learning to understand and work with these patterns rather than against them. Effective intervention for ADHD requires understanding these multi layered biological and psychological factors. Medication can be helpful by addressing neurotransmitter imbalances, but it's only one piece of a comprehensive approach. Addressing circadian rhythm disruptions through light therapy, sleep hygiene, and sometimes melatonin supplementation can significantly improve functioning. Working with gut health through diet and sometimes probiotics can support the neurochemical balance needed for optimal brain function. Environmental modifications that account for ADHD brain differences, like using timers, visual cues, movement breaks, and interest based learning, can dramatically improve performance and reduce stress. Psychological interventions need to address both practical skills and the emotional impact of living with a different brain. This includes developing executive function strategies, emotion regulation techniques, and most importantly, accurate understanding of ADHD as a neurobiological difference rather than a character flaw. While ADHD is fundamentally neurobiological, its impact is significantly influenced by social and cultural contexts. Educational systems, workplace environments, and social expectations that are designed for neurotypical brains can exacerbate ADHD challenges or, when modified appropriately, can minimize them. Understanding ADHD as a difference rather than a disorder shifts how we think about accommodation and support. Just as we provide ramps for people who use wheelchairs without considering this special treatment, we can provide environmental modifications for people with ADHD without stigmatizing their needs. The goal isn't to make people with ADHD behave like neurotypical people, it's to create environments where their brains can function optimally. This might mean flexible work schedules that accommodate circadian differences, movement opportunities that support attention regulation, or task structures that work with rather than against ADHD cognitive patterns. ADHD affects not just individuals, but entire family systems. When one or more family members have ADHD, it influences family dynamics, communication patterns, and stress levels in complex ways. Parents with ADHD may struggle with the organizational demands of running a household while also dealing with their own executive function challenges. Children with ADHD may need different parenting approaches that account for their neurobiological differences. Understanding ADHD as a family systems issue helps reduce blame and guilt while promoting more effective support strategies. When families understand that challenges stem from neurobiological differences rather than willful defiance or poor parenting, they can work together more effectively to develop systems that support everyone's needs. ADHD is often thought of as a childhood condition, but the research clearly shows that it's a lifelong neurobiological difference. While symptoms may change across development, the underlying brain differences persist. Understanding the developmental trajectory of ADHD helps set realistic expectations and develop age appropriate interventions. The hyperactive preschooler may become the restless teenager who becomes the adult who needs movement to think clearly. Executive function challenges that manifest as difficulty with homework in childhood may show up as project management difficulties in the workplace. The key is recognizing these continuities while also understanding how ADHD brain differences can be assets in some environments and challenges in others. The emerging neurodiversity movement offers a helpful framework for understanding ADHD as a natural variation in human neurology rather than a pathological condition. This doesn't minimize the very real challenges that ADHD can create, but it situates these challenges within a broader understanding of human neurological diversity. From this perspective, the goal isn't to cure or fix people with ADHD, but to understand their neurological differences and create environments where they can thrive. This requires both individual support and systemic change in how our institutions and communities accommodate neurological differences. Understanding ADHD through a neurodiversity lens also helps address the shame and stigma that often accompany the diagnosis. When ADHD is understood as a difference rather than a deficit, individuals can develop more positive self concepts and more effective coping strategies. The research we've explored today reveals ADHD as a complex, multi layered condition with deep biological roots and significant psychological and social implications. This complexity might feel overwhelming, but it also offers hope. Understanding the biological mechanisms of ADHD helps us develop more targeted and effective interventions. Recognizing the psychological impact helps us address not just symptoms, but the whole human experience of living with ADHD. Most importantly, this research helps us move beyond simplistic explanations and moral judgments toward a compassionate understanding of ADHD as a legitimate neurobiological difference that requires appropriate support and accommodation. The goal isn't to make people with ADHD fit into a neurotypical world, but to create a world that recognizes and accommodates the full spectrum of human neurological diversity. When we understand ADHD as a different way of being human rather than a broken way of being neurotypical, we open possibilities for genuine flourishing. Every person with ADHD deserves to understand their brain, develop effective strategies for managing challenges, and have their unique strengths recognized and valued. The research gives us the tools to move toward this vision of acceptance, understanding, and support. Thank you for joining me on this deep dive into the neuroscience of ADHD. Remember, understanding is the first step toward healing, and healing, both individual and collective, is always possible. Until next time, this is Esther Adams reminding you that every brain is different, every brain has value, and every person deserves to understand and work with their unique neurological gifts.